So in the previous example, all we were doing is we were doing like-for-like substitutions, and we're going to use that property now to actually solve a system. So before we weren't solving, we were just doing some algebraic replacements. Here we want to actually solve, which means we want to find out the value of x and y that work for both equations. Okay, to do that we need to eliminate one of the variables, and we're going to eliminate one of the variables by substitution. So here we need to have an equivalent that we can replace. So here I'm thinking I could probably get the y on its own. So I'm going to add y to both sides. I'm going to subtract 15 from both sides. So I get this y is equal to 4x minus 15. And now I can look for a like-for-like replacement here. So that y can be replaced with a 4x minus 15. So here then, I'm going to take this equation. I end up with 2x plus 2 times y equals 10. The y is replaced with 4x minus 15. Okay, I did a like-for-like replacement. It's balanced. Okay, and what was the purpose of doing that now? Now we have a purpose. We're trying to solve. The purpose was we want to get only one variable. So we only have one variable in this expression. That means we can solve this equation. So we can just expand the brackets, combine like terms. I'm going to add 30 to both sides. I end up with x equals 4. Remember that the system has a solution for both x and y. To solve for y, I substitute back into one of the equations. This one's the easiest because it's already equal to y, so it's an easy calculation. So I end up with 16 minus 15, so I get y equals 1. So if I were to graph these two relationships, we would end up being able to see that they intersect at x equals 4, y equals 1. So here we have a quadratic system. So now we have quadratics in terms of x squared. I want to do a like-for-like replacement. Now I could isolate the x squared and replace that x squared. In this case though, it's much easier, since this equation is already equal to y, this is equal to y, it would be much easier to do a replacement for this y with this y and this expression, or the other way around. It actually doesn't really matter which way I do it. So I'm going to replace this y with 2x squared plus 35, since they are equal. And now it's equal to the 3x squared minus 10. Again, I've done a like-for-like replacement. And the purpose now, because now we're solving, the purpose is I'm trying to solve for x. Okay, which means that I can only solve for one variable, and I have a one variable equation now. So I'm going to go ahead and add 10 to both sides. I'm going to add 2x squared to both sides. So I end up with 45 equals 5x squared. X squared is equal to 9. I undo the x, so I get plus minus 3. So now I have two solutions here, two sets of solutions. X is equal to 3. When I substitute x back in, I'm going to end up with 3 times 3 squared is 9, minus 10 is 17. So y is equal to 17. When x is equal to negative 3, I substitute back in, I'm going to end up with negative 3 squared is 9 times 3 is 27 minus 10 is going to give me 17 as well. Okay, and although I plugged it into this equation, I could have easily plugged it into this one, and it needs to give me a consistent solution. So if I plug 3 in, I get 9 times negative 2 is negative 18 plus 35 is positive 17. So this is consistent in both equations because The x and y, if it's a solution, has to be where they intersect, which means the x and y here must match the x and y here. So here we have some word problems where we're going to need to set up a system. So whenever we're doing word problems, it is important to establish what exactly are my variables. What am I looking for? So it says here the tickets to a play are sold for $25 for balcony, $40 for lower level seating. If the total revenue earned from the sales of 1,500 tickets is $5,400, this is a key. How many of each ticket are sold? Okay, that's where the question's being asked. That's where I can identify my variables. So what is unknown? The number of each ticket. Okay, so not the cost, because we already know the cost, but the number of balcony tickets. Okay, and also the number of lower level tickets sold. Okay, so those are my two unknowns. I have two unknowns. I need to come up with two relationships. So where are my two relationships? So I go back to my word problem. Tickets to a play are sold for $25 for the balcony, $40 for lower. Okay, well that's not an equation. The total revenue earned from the sale of 1,500 tickets. Okay, well I have the number of tickets here. I have the expression for the number of tickets here. I can come up with an equation. This is my first equation for the total number of tickets. Okay, so there's my first relationship. My second relationship is going to be based on $54,000. So how do I come up with an equation for $54,000? Well, I can't say 25 plus 40, that's 65. I can't say x plus y equals 54,000 because the number of tickets is 1,500, it's not 54,000. So the way I come up with the dollar value is I take the number of tickets for the balcony and times it by 25. So I get 25x. So the $25 times the number of balcony tickets. It's $40 times the number of lower level tickets. And when I add those two totals up, now this is dollars, dollars, it should equal dollars. So those are my two equations. So I'm going to use substitution to solve this. I'm going to substitute for y. So y is equal to 1,500 minus all the balcony tickets. And I'm going to replace that in my second equation. Okay, so equation, I should label that equation 1. Here's my equation 1. It's good to keep track of them so that we don't substitute the equation back into itself. So I end up with 25x plus 40y equals $54,000. Okay, so the y value is going to be replaced with 1,500 minus x. So I've done a like-for-like replacement. I've kept it all balanced. I only have one variable. I've done now what I needed to do. So I'm just going to go ahead and solve this. 25x plus, that's going to be 60,000 it looks like. Okay, minus 40x equals 54,000. Okay, so negative 15x. I'm going to subtract 60,000 from both sides. I end up with 6,000. 60 divided by 15 is 4. Negative 60 divided by negative 15 is 4. And I annex the two zeros, so I get 400 for x. Remember that it's a system, so we don't solve just for x. We need to back substitute into one of the equations. And since it's already equal to y here, I can solve for y. Y is equal to 1,500 minus the x, which is 400. Y equals 1,100 tickets. Okay, so we sold, looks like lower level seating is 1,100, and up in the balcony there were 400 tickets sold.